Our next speaker is a gentleman by the name of Keith McClellahan. Keith, where are you? All right. Keith, if you'd come up behind me and if you can work my PC and get your PowerPoint going, that would be wonderful. Keith is the principal and founder of Facilities Issues, a consulting firm specializing in publishing and benchmarking services. He's conducted numerous benchmarking studies for facility management organizations on sustainability issues. He's also the co-principal of FM Benchmarking, a web-based benchmarking performance measuring tool which provides integrated best practices, operating, and sustainability benchmarks. He leads industry benchmarking groups such as the Museums of Cultural Institutions, IFMA's Utility Council, Facility Managers Roundtable, R&D/National Laboratories, Telecommunications, and other benchmarking groups. Keith received his BS in engineering from Arizona State University. He's a registered professional engineer, a BOMA real property administrator with 37 years of facility experience in all areas, including construction design, project management, maintenance, operations, and facility management, so the full life cycle.
I actually brought along my own timer, but I don't think I'll use it. That's bigger. Okay. For those of you that I've lived here for 30 years. This is really a nice day. Do come back if you're thinking of moving to the Valley. Come back in June or July. I was at Sky Harbor when it reached 122, and they had to shut the airport down due to heat. Some of you know snow, but most of us don't think about heat. We got above the temperature curves on the aircraft takeoff weights, and no one knew what to do. Anyhow, I'm going to talk a little bit about automation's impact on benchmarking, but this has been really nice. I'm really enjoying the conversations and what's been said. I had never thought of this analogy until just the presentation before. I'm going to show you a tool that would allow you to take your, I'm trying to think of the most fuel inefficient vehicle, maybe a Hummer, and then turn your building into the equivalent of a leaf over time. So that's an analogy I had never used before. So I'm going to start off with a couple of questions. You know, most people benchmark for a few reasons. I'm assuming this group has got some. It sounds like I've heard benchmarking a few times, so I'm assuming that people have seen that. Most people benchmark or try to benchmark because they want to get a scorecard and they want to see where they're at. And let me just point out one thing. Some of the fallacies of benchmarking, I know not everyone's in facilities around here, but you know, if you see someone claiming that they're 10% better or something, there are at least 7 different ways you can measure square feet, probably a lot more than that in the world. And that may not be, you know, subtle differences in scores that way may not really do much. So here's my outline. It's fairly short. I'm going to show some of the key ingredients of a benchmarking system that works. Then I'm going to talk about putting some of the ingredients together, and then I'll show you some realized savings. Now, what I'm going to talk about is savings on the cost side, but all those savings translate into sustainability and environmental impacts. And we also track all kilowatt hours and carbon footprint and an equivalent energy consumption per some unit of area. But the examples I've got in here today are cost-based. The impact of automation on benchmarking, I think, is most people when they're comparing a facility don't have a real good, haven't had up until now a really good way to compare their facility against a good set of filters. The filters are really essential because if you're going to compare an office facility in the Phoenix area here versus one that's maybe in Bismarck, North Dakota, the consumption is going to look considerably different. Imagine, for example, if you're not going to just compare office facilities, we can compare an office facility to a manufacturing facility or a facility that operates 24/7 versus just a 10-hour-a-day shift. Maybe one that's got a high security requirement by the government, so everybody going in and out of the building has to have a security clearance. These are all important things if you're going to do that. So not unlike some other things today, benchmarking is the process comparing the building performance metrics, but we've taken it a little further so that you can see what best practices that improve performance. So it's a continuous improvement cycle that allows people to see what others have done and see what those best practices have impacted the cost picture and the operating criteria for that facility. By the way, a couple of things have been said here. In the life cycle of a facility, probably 10% of it is the construction cost. The other 90% is the long-term operating cost of the facility. And unlike producing a cell phone, the nice thing about a facility is you do have the opportunity to continuously renovate and upgrade the facility. You just have to know which items have the biggest effect. I've already talked about this. The fallacy of traditional benchmarking is you know where you're at, but you don't know why, and you don't know what to do about it. It's not terribly productive. It's an exercise not unlike some others we've talked about it here. The real value add is after you've compared your building and you have your scores, is what can you add, what can you do to improve those scores and bring your overall performance up, no matter where you stand in the range. Talk about these. I continue going down the outline. I'm going to talk about some data fields, filters, and best practices. The real, to me, this pretty much, I could stop here, but I've got another 8 minutes. Okay. Costs lead to best practices, which leads to sustainability and continues to cycle through the process. I want to correct a couple of misconceptions. Benchmarking doesn't have to be terribly tough to get the operating cost perspective. Really, you have to look at maintenance, custodial, security, and utilities. This percentage keeps going up every year. They keep stealing more from this side, which is counterproductive. It's not too surprising that what happens, budgets seem to be fixed, cost seems to be the highest measure of performance, so nobody gets any more money, they get less, they still got to pay the utility bills, so they spend less on maintenance, and the buildings look dirtier. To me, this is the key ingredients. Again, I put a little different order to them. You compare, you analyze, I'm going to show you bigger ones of these, and then you improve, and that's the basic assumption. It doesn't really matter what the axis is over here. This could be kilowatt hours per square foot, maintenance cost per square foot, per square meter, whatever you wanted to look at. You want to look at a filter set that's got a series of enough buildings in it that it's statistically valid, and you want to see where you're at. And because everybody's worried about somebody seeing how somebody else is improving, the only data point that matters in this case is yours, and that's the only one that's identified. You want to be able to take some filters into the picture so that you can do the right things with them. These seem to be the ones that most people hit when they're looking at. Climate's really important. Age, size, number of employees, business type, hours of use, carbon footprint, LEED certification. I wish I could tell you that LEED certification matches up really nicely with reduced operating cost. There isn't enough data to say that one way or the other yet. It doesn't seem to be just popping right up and saying it. The higher LEED standard you have, the lower your operating cost. I think I have some ancillary evidence of why, because some of the people operating the buildings don't even understand how to operate them. But this is I've got some better. I put this up. Wasn't sure how long the room would be, but so for example, one of the things you want to do is see after you've got your data, you would like to be able to see what other people have done in your quartile. And so one of the tools we provide is take there's hundreds of best practices in the survey, so you can see by percentage what percentage people have implemented in the various quartiles of the best practices. I think I've got a better example coming up. So some best practices examples, just in particular, I think this is mostly, well, this is maintenance, energy efficient lighting, describe a variable frequency drives, handhelds for maintenance crews, security, CCTV monitoring, contract reviews, just a sample. And the nice thing about this tool that we've learned, it's quite dynamic. People will suggest other best practices, and we can add to it and see what the percentage change of that looks like. Well, let me just show one very quick example of the impact of filters. This is our building over here, $2.33 a square foot, and we haven't filtered it. So there's the first quartile, the median, the third quartile point. Add some filters, maybe by size of facility. Now, I haven't changed any numbers here, but you can see that the first quartile doesn't change a little bit, but the third quartile is dropping a little bit. So it's just interesting as to how the data changes. Add a filter for the type of facility. Again, the first quartile doesn't move around very much, but the median is starting to drop a little bit, and the third quartile has come down even further. And then add climate type, and you really start to see some significant changes in here. And at this point, the first quartile has come up, and our performance, which was mid-second quartile when we started looking at the filters, has now moved up to almost the point of the first quartile performance. So filters can have a really significant impact. This is a chart right out of our right off the way the tool prints it. But there's our building. I've got an example here, straight out of the survey of what this individual has done in the way of performance. I just grabbed a screenshot off the energy conservation initiatives, and you can see from the percentages here, they could probably do some things that would make sense and improve their overall performance. Most of these are no's. Daylight sensing to turn off lighting. 69% of the people in his quartile are doing that. 88% of the people in the next quartile are doing that. So these are a pretty easy way to look at information. Doesn't look like, if I were going to suggest green roofs, vegetated solutions, currently have 0% of anybody in the survey that's done that. So you'd be kind of out on your own if you were going to jump to implement that one. And then I've got at least 5 years of history at this point. Most people, this is the median. So if I took a 100,000 square foot facility over a 5-year period, total cost savings from the 4 components that I listed translate into about $200,000 worth of operating cost savings, which all translate. Remember, 38% of it was on the utility side. So a large portion of those costs turn into fewer kilowatt hours being consumed in the facility. Other savings turn into fewer maintenance people working on trouble calls and doing more planned work to make the systems more efficient. So that's the bottom line: save money and reduce the carbon footprint through an iterative process of looking at best practices related to costs. Okay.
Wonderful.
Okay. 2 minutes.
Thank you very, very much. Questions?
Let's see.
Do I have some questions out there?
I see a hand up here.
Yes. What I'm curious about relates to something happened last week. Facebook came out with a standard called the Open Compute platform, where they standardized not just computer servers but the entire data center, and essentially they released under an open source license the specifications on how to build a data center. What I'm curious is why aren't there more initiatives out there to standardize building types that are commonly used throughout the country?
Great question. Let me take it on. I was talking to Angela, and I've learned not to put my hand up too much anymore lately. I'm on a committee. I won't be able to attend the rest of the conference because I'm off to an Oscar committee to standardize the data survey questions for the benchmarking survey, and I'm on the OmniClass committee to standardize the building type definitions that are. So we'll be having this committee work is really slow, but I expect that we'll have classifications for that in a year, as maybe sooner. I just am amazed at how long some of this takes.
I'm also amazed at how long some of this takes. And that's an initiative that we're embarking on right now on our own from a strategic point of view. We imagine some years into this. And the question for us, this comes back to these filters and the notion of what is the climate that we're working in and really understanding that climate. And now we need to understand how might that climate change over the next 20 to 50 years, because many of our buildings are going to last that long. And then also the critical question of type, because you've got to understand how that building is being used, how much equipment is in it, how many people are in it, how thick is it, how much heat is in it, how fast is heat moving through the building. So it's that use and the climate. And so what we're trying to learn is how to design to take that into account and developing a vocabulary that changes as we go around the world based upon the type of building. Any other questions? Well, Keith, I want to thank you very, very much.
Thank you.